This video is on translating word sentences into algebraic expressions and equations. Math is a language, and if you don't already know how to do some of it simply, you need to learn to speak and write it, and that's what we're going to practice here. If I write the expression x plus 3, and you had to read it to someone who didn't understand the symbols, the written language is different. What could you say? So this is just like any other language. If you looked at Chinese symbols, you wouldn't know what the letters stood for or what they meant, and you have to learn it, and math is the same way. One of the things that you might be able to say is some number increased by 3. X just stands for a number. So we don't know what that number is, so we just say a number or some number. Plus, increased by is a way of saying that, and then of course the number 3. Another way to say it might be a number plus 3. Yet another way might be 3 more than a number. Isn't that meaning all of those mean the same thing? 3 more than a number, x plus 3. All right, so what about 2x? I hope you know that when there's a number right in front of a variable without any math operation symbol like add, subtract, multiply, or divide there, I hope you know it's understood to be multiplication, always. And if you don't know that, now you do. A number directly next to a letter, a variable, means it's being multiplied. And so one way to say 2x in words is to say 2 times a number. Can you think of another way to say it? What about twice a number? Saying twice a number means you're going to multiply it by 2, doesn't it? And you might be able to think of even other ways to say that same algebraic expression. You'll be more likely to be given the words and then asked to write the number phrase or the sentence. Now you have to be careful. Sometimes it's just a phrase, and sometimes it's a number sentence that includes an equal sign. So there are certain things you're going to look for. One might be, if the problem is posed correctly, is there a period at the end of this word sentence? If there is, it's probably going to be an equation, a mathematical equation with an equal sign in it. That's the difference. A phrase would turn into a math expression. A real sentence will turn into an equation. Let's look at the first example together. In the first example, we have 7 more than 3 times a number. Let's translate this a piece at a time. More than, we saw that on the last slide. When we want more than something, it means we're adding to it. So let's just make ourselves a little note there. 3 times a number. That a number part, that's your x, your variable. We usually use x, but you could use any letter you wanted to. 3 times that is 3x. All right, so I have 7 more than 3 times a number. The only thing I might do differently, other than my little notes here, is to put the 3x first. Because when it says 7 more than that, it kind of indicates that you're doing 3 times the number first, and then you're adding 7. But of course, addition is the same backwards and forwards, so it doesn't make a huge difference in this case. 10 less than a number is equal to 15. All right, 10 less than a number. That means we already have the number. Let's do this in another color. We already have the number, but we want 10 less. So what are we going to do to the number, x? I hope you said subtract. We're going to subtract 10. Now this seems backwards because if you just translate literally here, you're going to have 10 minus x, but it's 10 less than the number. So you're starting with the number, you're subtracting 10. Is equal to, that's an equal sign, 15. All right, some number less 4 is 17. Okay, some number, that's x, less 4. Now look at the minor difference here. It's not less than some number. It's not starting with the number and subtracting something. It's some number less 4 minus 4, because less means you're taking it away, is equals 17. So x minus 4 is equals 17. All right, I want you to try the last two on this page. You can pause the video now, and when you come back, you'll take a look to see if you got it right. Okay, I hope you tried the problems. We have the sum of twice a number and 6 is 4. So sum indicates you're going to add your numbers together, whatever they are. So the sum of twice a number is 2x. And since I want the sum of this and 6, notice here, this is my sum plus of twice a number and 6. Is equals 4. So a little bit tricky. We had two things going on there. Okay, sum tells you to add the two things that are happening. The word quotient indicates division. If you're not familiar with it, you do need to remember that. You learned it way back when in elementary school. Quotient means division. There's a couple of ways that you could write this. The quotient of a number and 50 could just say the number x divided by 50. But now a quotient could be written as a ratio. So it is just as appropriate to write x over 50, like a fraction. The division symbol and the fraction bar mean and do exactly the same thing. The last thing that I want to talk about is that some problems deal with consecutive numbers. Now you might not know what consecutive means. So consecutive means one following another. An example would be 3 and 4 or 100 and 101. So it's just a fancy word for one number after another. Even -7 and -6, negative numbers can be consecutive too. Consecutive numbers would be next to one another on a number line. All right, so if the first number is just called x, what would we call the next consecutive number? Now some of you will know this right away. Others might need to think about an actual number. So let's say instead of x, the first number was 3. What would you have to do to that number to get the next consecutive number? What do you do to 3 to get 4? I hope you said you add 1. And isn't that true of every number and the next consecutive number? To get from 100 to 101, don't you add 1? Or even to get from -7 to -6, you're moving 1 over on the number line. That's adding 1. So the next consecutive number after x is x plus 1. What about the one after that? Wouldn't you add 1 again? So what's x plus 1 plus another 1? Well, it's x plus 2. Now we're going 2 over from the original number, 2 over on the number line. And so x plus 2 would be the next one. All right, so the example here that you'll see with consecutive numbers says the sum of two consecutive numbers is 17. So when you see that consecutive numbers, you're going to tell me one of them, and you're going to tell me the next consecutive number, so that's x plus 1. The sum of them means add them together, doesn't it? Sum, and then is 17. Now you're going to have to be able to solve these problems, but for now I'm more interested in the fact that you can translate it. I'd like you to try and solve this one by combining like terms and figuring out what those two consecutive numbers are. Mathematically now, not guess and check. Add x plus x, subtract 1 from both sides, divide by whatever's in front of the x. You're going to find out what x is equal to, and then you need the next number. To help you, I've given you some common math words and some hints about the way you might see them in sentences. And so you should zoom in on this, you should read it carefully, and you should make sure that you recognize these words in a sentence as indicating adding, subtracting, multiplying, dividing, or equals. We'll practice these more tomorrow.